electrolysis of dilute, don't mind my writing, sodium chloride, NaCl, aqueous solution. Now, I will be very fast. The ions in the electrolyte, that is in the electrolyte, what are the ions? We have same, Na plus, H plus, OH minus, and the Cl minus. So at the anode, which is the positive electrode, we are going to have Cl minus and the OH minus that will migrate to the anode. So which one will get discharged? Let me write my Cl minus clearer so you see it. Cl minus and OH minus. Remember, we are dealing with dilute solution now. And I said, if our solution is dilute or there is no halide at all, this is the chance. The chance for OH minus to get discharged. So we are dealing with dilute solution and dilute electrolyte. So OH minus will be discharged. Don't forget that. So how do we write the equation for the discharge of OH minus? OH minus, whenever it gets discharged, it will give you oxygen as the product at the anode. So how do we write the equation? So let's write it first. So we are going to get oxygen gas, but not only oxygen gas, we will also get water, more water in the electrolyte. Oxygen gas and more water in the electrolyte. So, but that will be electron as well, because this guy, in order to get the charge, it means it needs to remove electron. So let me write this one to the far here. OH minus loses electron to become water and oxygen gas. So we need to balance this equation in order to know the exact number of electrons that is lost by OH minus. We have 2 oxygen atoms and then 1 oxygen atom here and 2 hydrogen. So if you put 2 here, it means we have 2 hydrogen atoms, but we still have 2 oxygen here. So oxygen is not balanced here. So in that case, we can, if we want to balance oxygen, because oxygen has to be 4. So let's put 2 here. So if we put 2 there, it means we have 4 hydrogen atoms and 4 oxygen atoms. So you can just put 2 here. 4 here. So if you put 4 here, it means we are dealing with 4 OH minus. When there was no 4, it means only 1 OH minus loses 1 electron. Now when we have 4 now, it means 4 OH minus will lose 4 electrons. So you can see I put 4 now here because we have 4 OH minus. This is the way I like to write it, to show that electron is lost. But the convention that examiners want is for this negative, this charge, to be at this side. Whenever oxidation happens at the electrode, the electron will be at the right side. So instead of minus electron, it will now become positive at this side. Just like when you have A minus X equals B, A equals B plus X. So the sign will change when it crosses the bridge. So this is the bridge, our arrow. Minus 4 electron becomes plus 4 electron. Please don't forget this equation. If you like, you can memorize it. But it's not difficult to know. When you just know the product, there are going to be oxygen and water. Oxygen is going to be the product at the anode. This one will stay in the electrolyte. So is our product at the anode. Now, let's go to the cathode. At the cathode, remember, the competition is between sodium ion and hydrogen ion. So the good news is that nothing changes here. Dilution, concentration does not affect what happens at the cathode. So you just copy what we wrote here. Just copy it, as in what we wrote at the cathode here, and then you are good to go. Competition is still between sodium ion and hydrogen ion. So in that case, hydrogen ion will be discharged because sodium ion is an ion of a metal that is more reactive than hydrogen. So that ion will prefer to stay in the electrolyte, send hydrogen away to go and collect the incoming electron. When hydrogen gets to the cathode, it will collect the incoming electron and then become hydrogen atom. Because we cannot write it like this, we have to put 2 here to become hydrogen molecule, and then we put 2 here, that is 2 hydrogen ion, and then 2 electrons are gained. So this is the equation of the reaction at the anode. The product at the anode of the cathode is hydrogen gas, whereas the product at the anode is oxygen gas. You can see that we have different products. When we dealt with concentrated sodium chloride, the product at the anode is chlorine gas. The product at the cathode does not change, hydrogen gas. When we use dilute sodium chloride, the product at the anode is what changes to oxygen gas, whereas the product at the cathode does not change. So, what is the nature of the electrolyte after the electrolysis? Na plus, Cl minus, OH minus, H plus. You will get rid of the products. This one discharged to give us oxygen, this one discharged. So it means we still have sodium chloride. But if we look at what gets discharged, it is OH minus and H plus, which means what? It means water. So we lose the solution lost some water, and then it becomes what? It becomes more concentrated. So eventually the nature of electrolyte is what? NaCl Na plus and Cl minus comes together to become NaCl, and then NaCl will be more concentrated because we lose water. How do we lose water? H plus get discharged, and also OH minus that is H plus left the electrolyte, and OH minus also left the electrolyte to become hydrogen gas and then oxygen gas. So it means electrolyte will be less of water. When it is less of water, it becomes more concentrated in terms of sodium chloride. So that is the electrolysis of dilute sodium chloride. I think you can try that for the following electrolytes. So these are the 3 electrolytes I want you to try the electrolysis of aqueous solution, that is aqueous electrolyte on. So you can post your answer in the comments under the video. Thank you so much. See you next time.